All right, so this is the final video of this week, and this is the final technique that I'm going to show you, which is known as the elimination method. Now, this is a slightly sophisticated method. Okay, so this will require a fair bit of practicing because before you actually um, understand this fully. It's in some cases it can really help you, but in other cases it can be very long. Okay, so it's kind of like a technique or a method that I usually like to avoid as much as I can unless I really have to use it. Okay, so it's a powerful technique though. Okay, it's maybe one of the most powerful ones that you will see in high school, but it's a technique that's rarely used. So again, focus is to find the point of intersection. Okay, we're finding the solution of this system of equation, which is the same as finding the point of intersection. Okay, so you have two linear equations. You need to find the point of intersection. Now, you could use comparison, but comparison would be very long because you would have to either solve for y, but in both cases you're going to have to do a lot of algebra, or you could solve for x. And again, in both cases, you would have to do a lot of algebra. Okay, so comparison wouldn't work here. Comparison usually makes more sense to use when you have y is equals to something, okay, and then y is equals to something else, okay. Then it's really easy to use comparison because both of them are given in terms of y, okay. But when that's not the case, then you use substitution. But in substitution, it usually makes sense when one of the variables is already um, kind of like, so in this case you could do this by substitution. You could either solve for x or for y. So I'm going to actually use the second equation, which is something that I did not do in my previous equations, because you see it would be very easy to solve for x in this case. Okay, so this equation in red, if I solve for x, then all I need to do is just to get rid of this minus 2y, and then you can do that by doing plus 2y on both sides, right? So if you want, let me just do this for you. So plus 2y and then plus 2y, and then this will disappear, right? So and this would simplify to um, so this would just become x is equals to 2y minus 4. Okay, now substitution would make more sense because one of the variables is explicitly given to me, right? So x is equal to something, so I can substitute this x value into my first equation. Okay, so replace this x over here by 2y minus 4. So that is how substitution method would work. Again, you could solve for y, but if you solve for y in the second equation, you'd have to divide by minus 2 at some point to get rid of the coefficient negative 2. And in the first equation, you'll have to divide by 3. And in both cases, like, you're probably going to end up with fractions, right? So the best thing to do would be to solve for x in the second equation, not the first, because in the first, if you solve for x, you would still have to divide by 2, which will result in some fractions. Okay, so this would be the I guess the best way to isolate for a variable and then use substitution. Okay, so let's do that. I'm gonna do this question using substitution method, right? Because that's what we saw last class. I'm expecting you to do this on your own actually, because it's a starter question. Um, and then we're gonna do the exact same question using elimination. Okay, so let's make the substitution, right? So we have 2. Instead of x, I'm going to replace x by this stuff over here. So 2 times 2y minus 4 plus 3y is equals to 13. Okay, and again, remember the reason why we're using substitution method is now we only have one variable to deal with, and we can easily solve for that variable, right? So it's kind of like um, getting rid of one of your variables, okay? So get rid of your brackets, right? Because you have to combine like terms and stuff like that. So distribute this, and when you do that, you're going to get 4y minus 8 plus 3y is equals to um, 13. Okay. So, and again, this is a 3. Okay. So sorry about my handwriting. So now, right, get rid of the number. You want to have all your numbers on the right, variables on the left. So plus 8, this disappears. And then combine your like terms together, right? So the 4y will combine with the 3y. You add your coefficients together, right? The 3 and the 4 and the 3 will combine to give you 7. Leave the variable the way it is. And this becomes 21. And then just get rid of the the 7, divide by 7, divide by 7. So y is going to be 3, right? And then how do you find the x? Use this equation, because this one is already expressed in terms of x, and then you can easily figure out what x is going to be, right? So x is just going to be 2. Instead of y, I'm going to put 3. So 2 times 3 minus 4. So that's 6 minus 4, which is equal to 2. So your point of intersection is 2 comma 3. And to validate this, what I would recommend is plugging this into your equation on top and just check if you're actually getting 13. Okay, so let's just quickly do that. So 2 times 2 plus 3 times 3 is equals to 4, right? 2 times 2 will give me 4. So let me just clean this up. So this is equals to 4 plus 9, which is equals to 13, and which is what I have over here, right? So it does check out. Okay, so this is substitution, right? So solving for one of your variables, in this case x, and then substituting this x value into your top equation. Okay, so if you're solving for the variable in your second equation, right, in the equation in red over here, then it only makes sense to make the substitution in the first equation. Okay, and then you know, your first equation will only have one variable, right? Everything will be given in terms of y, so you can solve for your y value, right? And then once you solve for y, you can plug this y value into this equation to get the x value. Okay, and that is it. So this is kind of like, if you want, this is your final answer, 2 comma 3. And the stuff that I did on top was just to validate. Okay, so this was just me checking my work. But as you can see, this is kind of long. Okay, so substitution method, very powerful, but sometimes it makes sense to use another method. Okay, so comparison would have been even longer in this case. Okay, so now the question becomes, um, I guess the question becomes, why is substitution really long? The substitution is really long because you have to solve for x initially, right? Because to use substitution, one of the variables should be explicitly given to you, either x or y. Then it's faster. Then you can easily make the substitution. But if it's not given to you, then you will first have to solve for that variable and then make the substitution. Okay, so now let's focus on elimination. Okay, so this is how elimination works. We have an equation on top, okay, and we have an equation underneath. We're going to combine the two equations together and eliminate one of the variables. Okay, so what do I mean by that? Okay, so you see the first equation has a 2 in front of the x, and this equation has a 1 if you want. You don't see it, if you don't see it, so it's 1. Okay, now what I'm going to do is I'm going to make this equation similar to the first one. Okay, I want to get 2x in my second equation as well. So what I'm going to do is, to get 2x, there's only one way. I need to multiply the left hand side of my equation by 2, because 2 times, like when I start distributing, 2 times x will give me 2x. Okay, but remember, whenever you do something to the left hand side, you have to do the same thing on the right hand side. So if I multiply my left hand side by 2, I'm going to have to multiply my right hand side by 2 as well. Okay, so times 2 on both sides. So when I do that, my new equation becomes, right, if I distribute the 2, my new equation will become 2x minus 4y is equals to minus 8. Okay, they're equivalent. I've just created this new equation. Okay, and I'm gonna make use of this equation. Okay, so how will I do that? So let's write the top equation. So let's just pretend that the top one is in I don't know, let's just use a different color. Okay, so let's say this one was in purple. Okay, so maybe let me just circle this in purple. So let's copy down the equation in purple. You have 2x plus 3y is equals to 13. The equation in red, I'm going to write that underneath. Okay, 2x minus 4y is equals to minus 8. Now, right, once you have the coefficients that are matching for the same variable, what I'm going to ask you to do is, you either have to subtract or add. In this case, you will have to subtract, and I'll tell you why. Subtract. You're going to subtract the bottom equation from the top equation. Okay, so do the top equation minus the bottom equation. Okay, so when you subtract, make sure you're subtracting everything, and everything needs to be aligned so that you're not making a mistake. Okay, so 2x minus 2x will just give me 0. Okay, plus 3y minus 4. So minus minus makes it plus, right? So this is the same as saying 3 minus 4, which is 3 plus 4. So this gives me plus 7y is equals to 13, right? The 13 from here minus 8, which is 13 plus 8, right? Minus minus, remember, makes it positive. And if you're confused, just use your calculator, and then you're going to get 21, okay? So basically, after subtracting, right, after doing so, this, let's just call this equation 1, and this down here is in red is equation 2, okay? What I have up here is equation 1, sorry, I'll be consistent with my colors. I did equation 1 minus equation 2. Okay, so I did 1 minus 2. So basically, right, the top equation, which is 1, and then I subtracted 2 from it. Okay, and this is my new equation. But see, the idea is, the reason for doing that is because I was able to eliminate one of my variables. Okay, I was able to eliminate the x variable. Okay, so it's difficult. I couldn't have just subtracted the two equations directly, because if I do top minus bottom, I'm gonna get 2x minus x, which will still leave me with x. Okay, so you need to multiply the bottom equation by 2 first and then subtract. Okay, so which is what I've done. Okay, and by doing so, I get 7y is equals to 21. So I can solve for y. So divide by 7, divide by 7. So y is equals to 3. And then what you will have to do is solve for x up here. So in either one of those equations, it's easier to solve in this one. So if you do, x will just equals to, right, just move the 2y over. So you're going to get 2y minus 4. Okay, and then using this equation, you can figure out what x is. So x will just equals to 2 times 3 minus 4, which is equals to 6 minus 4, which is equals to 2. And your solution is 2 comma 3. Okay, so this is the point of intersection. And again, both of them have to be the same, right? 2, 3, 2, 3. Okay, so it's kind of tricky, right? Elimination is difficult. Why? Because you kind of have to really understand how to eliminate. Okay, so if I were to subtract this the way it is, it's not going to work. I won't be able to eliminate any of my variables, right? This is called elimination. Your goal is to eliminate one of the variables, so make sure that your coefficients are matching. The reason why I'm choosing the x's to match, it's because it's really easy to multiply this equation by 2 to get 2x. Now, if I could also get my y's to match, but you see the 2 and the 3, it's kind of confusing, right? Because you're going to have to multiply both equations by something for that to work, and we're going to do that in maybe the last example. Okay, so anyway, so I hope this is kind of making sense. So let's do one more. Okay, so we have this equation and we have this equation in red. So let me just be consistent with my color. So this one I think was I was using purple for this, and now I'm going to use red for the second one. Okay, which is I think what I did in the previous question. Yeah, so I need to eliminate something. You see the 4 and the 3, this is tricky. I cannot really eliminate the x's because, 3 times 2 is 6, right? It doesn't really give me 4. But you see, the y's are nice. Okay, so if I focus on the y's, this one is 2, this one is minus 2. So what I can do is I can actually multiply the bottom equation by, you could multiply by minus 2 to get plus 2y on both sides, but I'm going to do something different. I'm going to actually multiply this by 2, okay? And you'll see why in a moment. Because if I multiply this equation by 2, so again, you have to multiply the whole thing by 2, right? So one way to think about it is that you put the brackets and then you multiply the whole thing by 2, but that might confuse you. So if it's confusing you, just remember that you have to multiply the left side by 2 and then do the same thing to the right-hand side. So if you do that, then you have to distribute the 2. Okay, so this is kind of tricky. And then when you do that, you're going to get 8x, and then minus 2y is equals to 20, okay? Now I'm just going to write this equation in purple again down here. So the equation in purple is minus 3x plus 2y is equals to 5. Okay, so this is a 2. Sorry about that. So 2y. And then the equation in green is 8x minus 2y is equals to 20. Now, what should I do? So in the previous case, I had to subtract, right? I had to subtract because I had the same thing on top and the same thing at the bottom. So 2 minus 2 will give me 0. Now I'm going to ask you, what do you think we should do down here? Okay, what do you think we should do down here? So let's just change this to green so that um, my colors kind of match. Okay, so I'm just gonna change this to green. Okay, so what do we need to do? So you have plus 2 over here. What should you do to plus 2 and minus 2 to get 0? If you subtract, then you're going to get 2 minus minus 2, which will give you 4. So subtracting wouldn't help you, right? And some of you might have guessed it. You're going to actually have to add in this case. Okay, so when it comes to elimination, you can either add or subtract the two equations. Okay, so this is, if you want my equation in purple, right? This is equation 1, and this is equation 2. And all I have to do is to add the two equations together. Okay, so I'm going to add them together. So minus 3x plus 8x, right? Minus 3x plus 8x is 5x. 2 plus minus 2 gives me 0. So you can just say plus 0, but I mean, it's up to you. I would just not put anything because it's plus 0, right? You don't have to put the plus 0. But if you want, okay, let's just do this because I don't want to confuse you. Now you have 5 plus 20, which is 25. Okay, so basically 1 plus 2, right? Equation 1 plus equation 2 simplifies to this. Okay, and I can simplify this a step further. This is just 5x plus 20. Oh, sorry, 5x. I'm going to remove the plus 0 now. So 5x is equal to 25. So you can easily solve for x. Just divide by 5, divide by 5. So x is going to be 5. Okay, now how do you solve for y? Just use either one of the two equations, either this one or this one, solve for y. Okay, it's easier to solve for y in this case because all I have to do is just move the y over to the other side, or if you want, just do plus y plus y. Okay, so if you do plus y, then this equation becomes so this will cancel, right? You're gonna get 4x is equals to 10 plus y, and then you can just get rid of the 10 by doing minus 10 minus 10, right? So that means y is just equals to 4x minus 10. Okay, and then using this information, right, again, I could have solved for y in this case, but it would have been longer because I would have to divide by 2 at some point. Okay, because I need to get rid of that coefficient, so that's why I didn't use that. But anyway, so using this red box, I'm going to figure out what the y value is going to be. So y is equals to 4x minus 10, but now I know that x is equals to 5, so I'm just going to replace this by 5 and then just do this. So 4 times 5 is 20. 20 minus 10 is just equals to 10. Oops, 20 minus 10 is equals to 10. So your solution is, right, x is 5, y is 10. So this is your point of intersection. Okay, so this is kind of like, if you want, this is your final answer. And to convince yourself that you're right, what I would recommend is plugging this value into your first equation just to see if you're getting 5. Okay, so let's just quickly do that. So x is 5, y is 10. So minus 3 times x, but x is 5, plus 2 times y is 10, is equals to, so minus 3 times 5, that's minus 15, plus 20, that's equals to 5, which is what I have here. Okay, so it checks out, guys. Okay, so again, this is me doing extra work, but when I do that extra work, I feel really confident about, all the fancy algebra that I've done because I know now that I did everything correctly. Okay, so please get in the habit of doing this. Now, this is the general case. Okay, the general case is when it's difficult to multiply one of the equations by something to get to the other equation. Because if I multiply the 3, I'm going to get 6 and then 9, right? I'm not going to get 5. And it's the same thing over here, okay, with the 8 and the 6. If I multiply 6 by 2, I'm going to get 12, 18, 24. I'm not going to get 8. Okay, so this one's tricky. So what you have to do is look at your lowest numbers. In this case, my lowest numbers are 5 and 3. And you have to find the lowest common multiple. Okay, so basically, if you want, it's kind of like I'm asking you to find the common denominator of 3 and 5. Okay, what's the common denominator? The lowest common multiple. And you can kind of convince yourself that it's 15, right? Um, it doesn't have to be the lowest common multiple. Any common multiple will work, but lowest common multiple will make your work less messy. So if the lowest common multiple is 15, then you have to ask yourself, by what do I need to multiply this 5 by to get 15? And the answer will be 3. And remember, you're multiplying everything by 3. Okay, so I'm just kind of like doing the shortcut. You're multiplying your left hand side by 3 and also your right hand side by 3. Okay, so if you want, I'm just going to distribute this over. So I'm multiplying everything by 3 over here. And in the second equation, I'm going to multiply the second equation, because remember, my LCM, maybe I should write this. Okay, up here, my LCM, my lowest common multiple is 15. So what do I need to multiply the second equation by to turn this 3x into 15x? And the answer is 5. Okay, and again, this 5 will multiply everything. Okay, so make sure you're multiplying both your left side and your right side. So now let's rewrite these equations again down here in red. So 5 times 3 is 15x, right? So let's just not waste too much space, because usually I run out of space by the end. So 5x times 3 is 15x. 8 times 3 is 24. So 8 3 is 24y. And then 29 times 3, this is where you would have to use the calculator, but I think it's 87, okay? Because the trick is 30 times 3 is 90. And then you just have to remember that 29, there's one less. So 1 times 3 is 3, so just do 90 minus 3, but I'll just use my calculator to check. Okay, yeah, it is 87. Okay, and the second equation, multiply everything by 5. So this will be 15x, and it should be, right? They should align, because then I'm going to ask you the question a little later. You're going to have to do something. 6 times 5 is 30, so this is 30y. And then 21 times 5, I think, is 105. Okay, so let me just double check this. 630, 21 times 5 is 105. Okay, now you have these two equations, right? The equation on top, let's just call this equation 1. The equation underneath is equation 2. And you'll have to do something to both the equations to eliminate one of your variables. Okay, what is that? So if I add the two equations, then the 15 and the 15 will give me 30, which wouldn't work. So addition works when your coefficients have the same value but opposite sign, right? If I had 15x and minus 15x, then I would add the 2. But because they're one and the same, I would have to subtract in this case. Okay, so if I subtract, I'm going to get again, it doesn't really matter. You could subtract 1, do 1 minus 2, so top minus bottom, or bottom minus top. It doesn't really matter, but whatever. Let's just do top minus bottom to be consistent. So this just becomes 0. And, this will become, actually, it will become minus 6y. Minus 6y. And this is tough. So 87 minus 105, using my calculator, is minus 18. Okay, so that means my new equation is minus 6y is equals to minus 18, and I can easily solve for y by dividing by 6 on both sides. Okay, so y will just equals to 3 in this case. Now, how can you solve for x? That's the tricky part. Okay, that's where you'll have to use one of the equations and solve for your x. Now, the top equation, you could use that, but you see, 29 is not divisible by 5, so I wouldn't do that. Neither is 8. Okay, so a wise thing to do, you're going to have fractions, but it's going to work. Wise thing to do would be to solve for x in the second equation, because again, 21 is divisible by 3, and so is 6. Okay, so that's what I would do, but like I said, it doesn't matter. Okay, you're just going to have decimals in the first equation, but it's still going to work. But I don't really like decimals, so I'm going to solve for x over here. So I'm going to do minus 6y on both sides, so this will disappear, and then you're going to have 3x is equals to, again, you can write this however you want. So just make sure you're dividing. Okay, so 21 minus 6y, And then the final step is to get rid of the 3. So divide by 3, divide by 3. Make sure you're dividing both the 21 and the 6. Okay, so division kind of works like multiplication, where you'll have to distribute this to both of them. Okay, so make sure you're dividing both of them. And if you do that, you're going to get 7 and then minus 2y. Okay, so using this, so this tells me that x is equals to 7 minus 2y. So x is equals to 7 minus 2y, but I know what my y value is, right? My y is just 3, so I'm just going to do 7 minus 2 times 3, which is equals to 7 minus 6, which will just give me 1. So my point of intersection, right, x is 1, y is 3, is just 1, comma 3. And if you want to convince yourself that this is the right solution, check both equations. If 1 comma 3, if you plug 1 comma 3 in here, if it gives you 29, I'm going to quickly do this in my head. Yes, it does, okay, because 5 times 1 is 5, 8 times 3 is 24, 24 plus 5 will give me 29, okay, so it does work out. Now check if the second equation also is true, okay, so 3 times 1 is 3, 6 times 3 is 18, and 18 plus 3 will also give me 21. So I've done this correctly, okay, so um, that means this is my final solution if you want. Okay, so again, for those of you who understood these 4 example questions that I did, sorry for the long video, you guys are good. You can just go ahead and do the homework questions. So do question 4, 5, 6, 7, and 8. For this would be in your this section. Okay, so this is elimination. Elimination. So this will be underneath the heading elimination method. Do questions 4 to 8. Okay, 4, 5, 6, 7, and 8. Now for the bonus question, you need to understand how this works first for you to be able to do the bonus question. Okay, again, bonus question is optional. So I'm going to go ahead and do the bonus questions for my students who would like to challenge themselves a little bit more. But for those of you who, would like to stop over here, you can do so. Okay, this is kind of like optional. Okay, so don't worry about that. So what we have over here is we have to calculate the perimeter. So the perimeter of a rectangle is equal to 60 centimeter. Okay, so you have this rectangle initially. So let's just call this x. Let's just call this y. Okay, and the perimeter of this rectangle is 60. So perimeter over here is 60 centimeters. But if the length is doubled and the width is tripled, then the perimeter changes, right? So if you double the length, so this is your length, so I'm going to double this, so this becomes 2x. And if the width is tripled, so if I triple this, then I'm going to get 3y, then the perimeter becomes 144, okay? So now I have my 2 equations. Okay, my 2 equations are, how do you find the perimeter of this rectangle? You just have to add all the sides up. So you're gonna have, if you add all the sides up, right? So x plus y plus x, you're just gonna have, so this is x. It's just going to have 2x plus 2y is equals to 60 because the perimeter is 60. And the perimeter in the second example is 2, not 2x. So this is also 2x. Oops. So this is also 2x. This is also 3y. So if you add everything up, combine your like terms, right? So the 2x plus the 2x will give you 4x. And then 3y, maybe let me use a different color. So the 3y and the 3y will give you 6y. Okay, so the second equation basically will simplify to 4x plus 6y is equals to 144. So these are your 2 equations, right? I'm just gonna write the, I'm just gonna multiply the first equation by 2. Okay, so I'm just gonna multiply this by 2 because then I can eliminate the 4x. Okay, so if I do that, then this becomes 4x plus 4y is equals to 120. And my bottom equation is 4x plus 6y, 6y is equals to 144, and I can subtract the 2, right? So again, I'm doing this very quickly. So this just becomes 0, and then you're going to get minus 2y is equals to minus 24. And then just divide by 2, right? So if you divide this by 2, you divide this by 2, then you're going to get y is equals to minus 12. I think I may have to add a new page, so just give me 1 second. Okay, so y is equals to minus 12. Now solve for x, either in this equation or that one. It doesn't really matter. I'm going to use this one because I think it's slightly easier. So if I solve for x, I'm going to get 2x is equals to minus 2y plus 60, and then just divide by 2, divide by 2. So x will equals to minus y plus 30. Okay, and then I'm going to plug this y value down here. So x will equals to minus, remember y is minus 12, so minus 12 plus 30. So if I do that, then I get, so minus minus will become plus, right? And then 30, this will become 42. So your solution is x has to be 42, y has to be minus 12. Actually, I have to divide this by minus 2, right? Minus 2. And then this should be plus 12 because you cannot get a negative number. Okay, so this has to be 12. Yeah, positive 12. And then you're going to substitute positive 12 in here. Sorry. I was able to catch my mistake before it became too late. So, because remember, your length cannot be negative. Okay, so if this is so 30, so this is 18 then, right? So 30 minus 12 is 18. So that means x is 18, y is 12. Okay, and then just check if this is the right answer. Okay, so plug in 12 here. Okay, so this is 12, this is 18, and calculate the perimeter. Does that really give you 60? So 12 plus 18 plus 12 plus 18 gives me 60, and then do the same thing over here. So if this x was 12, then this would be 24, right? And this guy will be 18 times 3. 18 times 3 is 54. So one way to quickly check is just to do 12 plus 54 and then multiply that by 2, and that does not give me 144. Hold on, let me 18 times 3 is 54, and then you do 12 times 2, so plus 24, and then times 2, 156. So that means I probably made a mistake somewhere because I was rushing. So I'm getting 60 over here. 3, the width has tripled. Oh, it's 18 and 12. Sorry, it's 18 and 12. So this has to be, yeah. So I did do this correctly. I'm just checking it wrong. Okay, so x is 18. Okay, x is 18. Y is 12. Now this will work. Okay, 18 and 12. Right? So remember, x is 18, y is 12. And then if you check this out, then it will work. Okay, so just do 18 plus 12. And then multiply that by 2, you're going to get 60. So if this is 18, then that means this has to be 36, right? So let me just double check. 18 times 2 is 36. And then the other guy will be 12 times 3, which is also 36. 12 3 is 36. So just do 36 plus 36 times 2, and that's 144. Yeah, so this does work out. So you see, it is very important to always check your work. Okay, you could have even checked up here, right, just to see if you're getting 120 and 144 using that combination. Or if you want, you can just check the rectangles, kind of like I did. But if you do your algebra correctly and everything correctly, then you can easily find the dimensions. Okay, so this basically tells me that what is my x? My x is my length. Okay, so initially the length was 18 centimeters, right? And the width was 12 centimeters, okay? So yeah, so sorry about the long question, Bonus question is very similar. Again, this is bonus, right? So it's optional. If you're not getting it, don't worry about it. I'm not going to give you a question this difficult on your test. However, I'm still willing to help you on Thursday during my office hours. Okay, so sorry for the long video, guys. Thank you for watching. You guys have a nice day, okay? Bye.